Hello, Jijil. So I have another very interesting data sufficiency question. Yeah. So
Sure.
let's go to the question and see what question stem says. So it says that there is a school administrator and he assigns each student in a group of n students to one of m classrooms. So there are actually total n students. Okay. There are total n students.
Okay.
Now each of these students are assigned one classroom. Okay, so this is, let's say, classroom 1, this is classroom 2. So one students, each of these students are assigned some classrooms, and there are total of m classrooms. Okay, so these n students, they are assigned one of each of them are assigned one of the classroom. Okay, such that each classroom has same number of students. So number of students in classroom 1 is equal to number of students in classroom 2 is equal to number of students in classroom m. Does it make sense?
Yeah, in a way it's like a divisibility, multiple kind of question.
Exactly. So there are total n students. They are assigned, each of them assigned one classroom in such a way that each classroom, each of the m classrooms has equal number of students, right? Now you're also given that this m, okay, this number m is greater than 3. Definitely m and n are going to be integers because number of students and number of classrooms, right? So they are going to be positive integers. So m is between 3 and 13. Okay, so m could be any number between 3 to 13. So it could either be 4, 5, 6, 7 up to 12. Also, you're given that n is greater than 13. So n is any number greater than 13. It could be 14, 15 or any number. Okay, so now your question is, you have to find out, it is possible to assign each of the, now they're actually asking that if it is possible to assign each of the students, each of the n students to one of the m classrooms such that each classroom has equal number of students. So that actually your question is the number of students in each classroom is equal. Okay, so total students are n. So basically what they are saying,
Can I interpret it like this? Question is asking, is km equals to n such that k is also an integer?
Right.
Is that the meaning of the question?
The question, basically, or we can, in more simple term, we can say, is m a factor of n? Can I say that? Yes?
Yeah.
Or is n a multiple of n? That's the simple question. Makes sense? So I hope you understood from here to here. This is what the question is all about. That's all. Is m a factor of n? That's the question. Okay. Let's go to the statement and see. So statement 1 says that it is possible to assign each of 3n students one of m classrooms such that each classroom has same number of students assigned to it. So basically, in short, it is saying that 3n is a multiple of m, or let's say m is a factor of 3n. That's the information given, isn't it? That's the information that's given. Now, does this help? Does this answer your question? See, if m is a factor of 3n,
it may or may not
may not be, right? Let me give you some example. Let's say the value of your n is 14 and let's say the value of your m is 6. Now in this case also 3n, 3 into 14 will be a factor. So m will be a factor of 3 into 14. Yes? Yes. Now, right. But
Amrita,
yeah.
I understood this way. Essentially it says, this one says 3n divided by m is an integer. Is that correct?
Exactly. This is an integer, right? This is an integer. Of course, it's given to you. So even if n is 14, m is 6, this will, if you just substitute these values, 3 into 14 by 6, this will be an integer, isn't it?
Correct.
So does it answer my question? Is m a factor
No.
of 14? No. Your answer
No,
is
it's
no.
not.
It's not. Now, let us look at other way. Let me take another example and try to get a yes.
Let's
Because
say n is equal to 12. N is equal to 12.
yeah, if you take n is equal to 12 and let's say m is equal to 6. Now again, this entire thing 3 into 12 by 6 will be an integer. Okay, but this time this is a factor. M is a factor of n. So yes. So you see you're getting contradictory answer. For some values you're getting no. For other values you're getting yes. For that reason, this statement alone is insufficient. Right? Okay. Now, let's move on to statement 2. And let's see what is given in the statement 2. So your statement 2 says, it is possible to assign each of 13 n student, okay, to one of m classrooms so that each classroom has the same number of students. So in short, it is saying that m is a factor of 13n. Right. Now, does this help? This is given. So if you remember, just remember this. Let me write it down that m is between 3 and 13 and your n is definitely greater than 13. And it is given that m is a factor of 13n. So you see, can you conclude that?
Yeah, yes. Can I translate it like this? 13n divided by m is an integer.
Right.
And also because 13 is a prime number.
Right. And also m can never be 13 or a multiple of 13, you see.
Right.
M
so m,
is,
if it is divisible, it's not because of 13.
Exactly.
It must be because of the n
is,
alone.
M is not a factor of 13 for sure. Right?
Correct.
So definitely m is a factor of n. So definitely m is a factor of n. Then only you can divide and get an integer. M is 13n is divisible by m. So this alone, this statement alone is sufficient, right?
So it is B, is it?
So answer is B. First alone is not sufficient, but second alone is sufficient. I hope this helped. Thank you.
Thanks, Amrita.